Mrs. Muthuminal R, Assistant Professor at the Department of Agricultural Engineering. The previous class we have seen something about routine characteristics that comes under the subject Irrigation and Drainage Engineering for third year Agriculture Engineering Department students under the unit Soil Water Tension and Measurement of Soil Water. So, as a continuity of last class, we have seen something about what is irrigation, why this irrigation is important, and also we have seen how the plants get water from soil, also how much quantity of water will be available for the plant growth, and also what are the levels that could be splitted up in between the soil water to the root, and also the water which goes towards the groundwater. So these are something which we have seen. As I have said that among the 100%, only 50% of the water gets holded up as a capillary water. That is, two forces will act upon. One is a capillary force and the other one is a gravitational force. And the capillary force is usually the force that acts against the force of gravity, and it is held in the pore space. The water which is held in the pore space is represented as the capillary water, and also the water that is in excess quantity will get dripped away, that is drowning away of that excess water into the groundwater table. It drains downwards due to the gravitational force. That is what we called as gravitational water. These are the two primary ways that the water held is in the soil for plants to use. Okay, so these are something which we have seen at the previous class, until which the interaction between the soil and water has been seen. Today we'll continue this topic and we'll go in an elaborate manner until the soil water tension and stress. Okay. Before I like to go into the water holding capacity, I like to ask something that we have seen at the previous session that the water available is obviously used by the plant for its own growth, and only 1% of the water stays in root pad and the remaining gets over to the leaf surface, which will be transpired with the help of transpiration, and it will be utilized by them for photosynthesis. This is what we have seen, right? So why do we need so much amount of water quantity? Have you guys heard of it? Right. Here I like to quote an example. Okay. Then you have been, I hope many of them will have been having a capability of growing a plant. Even one plant is necessary for us to grow in our own garden, right? Wherever you go, whenever there is a place where a vacant place is available and that place belongs to us, we'd like to plant certain crops. For example, at my home, when I was in childhood days, I used to plant rose plants. It is a plant which gives us lots and lots of roses. So the water absorbing capability of that plant is different from that of the agricultural crops that nowadays we are going to discuss in the near soon classes. So why I'm saying that every plant has a root capacity, which we will cover them with the soil in a conical manner. So, and also we would have been asked to pour the water at the sideways in order to avoid the soil erosion. Because when we are utilizing the water in a very forced place, what happens? The soil gets eroded and the nutrient also goes away. So that is a common myth which we have been following until now, right? So here I like to say that since we have been thoroughly saying it as that the soil nutrients will go away, so the plant is not capable of growing the flower, and it is not possible for us to grow any more flowers, and the plant will not go away, it will reach into a wilting point. These stages, these stages which we have been saying have been dependent upon the capacity of the soil. So that is what we say it as water holding capacity. As you guys can see here, I have shown in a picture also, and also I have quoted in an italic manner that from the left I have shown that it is a field capacity where the pores have been filled with the help of water, and some capillary pores are filled with air. Okay, that means that most of the pores are filled with water, which is full, and the right drawing shows that it is a wilting point. The water available to the plant is exhausted. That means that the capacity of the holding capacity of the soil is very limited, so that the water has drained off, and also the availability of the water to the plant is really low. So this shows the soil moisture available, that is available to the plant. Fine. Usually, the level of water available is dependent over the four important levels of soil moisture content that is reflected in this. The first one is saturation, the second one is field capacity, third one is wilting point, and the fourth one is overdrive. Whenever the soil is saturated in the sense whenever the soil is having a certain moisture, it will be having certain water content in it. If it is saturated, then it means that the soil pores. Every soil particles will be joined towards together, and the voids will have certain pores in it, and those kinds of pores will be filled with water, and nearly all of the air on the soil has been displaced by water. That means that we are trying to replace the availability of air with the help of water. The water held in the soil between the saturation and field capacity is usually a gravitational water. Frequently, this gravitational water will take few days to drain through the soil profile, and thus some can be absorbed by the roots of plants. This is what happens everywhere. Fine. So this is the mechanism that happens whenever the availability of water has been absorbed by a plant, and whether the water available goes to the water table or it goes to the plant's root depends upon the soil capacity. Fine. So here we have to note it down that there are four different ways, and they are really important for us to remember it again. What are they? One is saturation, second one is free capacity, third is a wilting point, and the final one is an overdrive. So this is what I was trying to say as a continuity of the previous class. That is, we have seen at the previous class the interaction of soil and water. Today we have seen something about the water holding capacity of soil, and at the next session we'll see something about soil moisture tension. Thank you. Have a nice day.